Good morning students. In today's video we are going to cover this topic, that is Pratt's theory. Okay, like it comes under the views on isostasy. Okay, Pratt's theory. So proposed by Pratt 1855, he was a Cambridge trained mathematician studying the Himalayas. Okay, so he was a Cambridge trained mathematician studying the Himalayas. Height of land depends on density of crystal blocks, not thickness. So what he says in his theory, that the height of the land, like the mountains, these these are like this because of the density of the crystal blocks. That means the crust, not not the thickness of the crust. So density is what matters in his, according to him, not the thickness. All crystal blocks have uniform thickness, but they have different densities. High mountains, low density rocks, lighter, rise higher. So what he says, that the mountains are like less denser, because of that they are able to rise higher, and the plains and the low areas, they have high density rocks, that's why they sit lower. So they are denser, means you can simply say that they are heavier, that's why they sit lower, and they are not able to rise higher like the mountains. Pressure at base is equal everywhere because lighter rocks stand higher, heavier rocks sit lower. So because of this, that the lighter rocks stand higher and the heavier rocks sit lower, because of that the pressure at the base is equal everywhere. Okay, I will show you the diagram, don't worry. Elevation differences arise from density differences, not thickness differences. So what he mainly says in his theory, that everything is just because of the density differences, not because of the thickness differences. So let's see a quick comparison between the Airy's theory and the Pratt's theory. Both theory are important. Why? We will cover that also in a fraction of second. So density is same everywhere according to the Airy, and thickness different. So mountains have deep roots because they have thick crust. Okay, and according to Pratt's theory, density is different and thickness is same. Mountains are high because they are made up of lighter rock, so they are less denser, because of that they are able to rise higher. According to Aries, they are density same everywhere, but the thickness of the crust, if the crust is very thick, so because of that they have the deeper roots as well as they rise higher because of the thickness of the crust. Okay, so let me show you a diagram, a quick diagram to help you understand this concept. Hey, to help you understand the difference in the Airy's theory and the Pratt's theory. So Airy and the Pratt. Sorry. Okay, so in Airy theory, here we have these blocks, and 3 3 3. So what does this 3 denote? This 3 denotes the density. So density is same according to Airy, uniform density, but these differences in height represent the thickness. So thickness are different, but the density is same. Okay, thickness is different, density same. And in the Pratt, let's draw this line. Here's the block, here's the second block, here's the third block, and they are all say at the same level below. Let me draw this a little bit cleaner. Okay, so they are all at equal level below the surface. 3 4 5, that means they have different densities, so varying densities. Okay, and varying density, but they have same thickness. So they have same thickness, that's why they are equal. Different thickness, not equal. And yeah, okay, so that's a diagram that these are the diagrams showing Airy and Pratt's theory. What they said: same densities but different thickness, different densities but the same thickness. Okay, okay. Which model works where? So that doesn't mean that Pratt's model is not good or Airy's model is not good or both model failed. No, no, they are good, means they are useful at different places. Let's see how. Good for continents, good for explaining mountains and plateaus, not good for ocean depths. Works better for oceans because density variation explains sea floor differences. So here Aries model is good for the continents, and the Pratt's model is good for the ocean depths. Okay, so they are both good at their places, at different places. I hope this topic is clear to you all. If you have any doubt, you can freely comment down below. That's it for this video. Thanks for watching. um,